one is next?
Next is the bottom of that same slide.
Okay, yeah.
That looks.
Okay. Hello, everyone. I'm Travis. I'm a developer at Melonport, a smart contract developer specifically. So I know we're a little bit short on time, so I'm going to try not to bore you with too much detail, but I will describe at the beginning generally what it takes to develop smart contracts and what we do to do that. Then I'll describe sort of the present state of smart contract development, and then I'll talk about what I consider to be the next generation of smart contract development, and I'll use Melonport's technology stack as sort of a case study for that. So the next generation. This is the obligatory pop culture reference. I don't really watch Star Trek, but hopefully this makes the slides more relatable. But anyway, there's not going to be any more jokes. It's just going to be reading lines of code from now on. I'm kidding. So what does smart contract development actually entail? So there are several parts. The first part would be actually writing the code. Well, the first part would be to have the idea. Then you implement your idea in code. So right now, smart contracts are generally programmed in Solidity, and that's what this talk will focus on. Then you have to compile to bytecode. So you take the Solidity code, you run it through a compiler, and it spits out some bytecode for you. So this is something that the blockchain can understand. The blockchain doesn't run on Solidity. It uses bytecode instead. Then you have to deploy that bytecode. So deploying is just as simple as pushing this bytecode from the second step onto the blockchain. So when we deploy that code, we call it live. So now we can interact with that smart contract as a real sort of organism on the blockchain. And then beyond that, there's also supporting work. So that would be things like testing. Testing generally, just for the unacquainted, is software testing rather, is actually making sure that our software does what we think it does or what we want it to do. And then providing an interface. So an interface is just how someone could interact with our smart contract. So that could be something like what Mona mentioned, which is the Melon front end. That would be an example of an interface. This is the code for our smart contract, the main smart contract we use, which is the fund. So just try and memorize that because I'll quiz you on it later. And this is the sort of state of, or yeah, the present state of development, what people usually do right now with smart contracts. They usually use a framework called Truffle. It's by far the most common. And it helps with those things that I just mentioned. So that'd be things like testing, deployment, compilation, like I mentioned earlier. And we used it to get to where we are today, or at least a few weeks ago. And then we sort of changed gears and said, you know, we're running into a couple limitations here, and we want to, you know, try something that's a little more custom fit to exactly our purposes. So I'm not going to get up here and, you know, sort of diss on Truffle or anything like that, but we're definitely trying something a little bit different now, and something, like I mentioned, that's a little bit more tailored to what we want to do. So Truffle's a very large project, and it's also, I guess, fairly complex, and they do, you know, a pretty good job with that. But we wanted something that was definitely more simple, so we started up a GitHub issue, and Reto and I were sort of talking back and forth. Maybe we'll try this, maybe we'll try that, maybe we'll try DApp. There's another framework called DApp Suite. So then one of the developers, Daniel Brockman from DApp Suite, chimed in on the GitHub issue, and he basically summed it up. He said, it's very simple. He's talking about DApp. It's very simple. It almost doesn't even do anything. So if you like not doing things, you don't even know what they are, then this is for you. So, you know, so with that, we were like, yeah, this is exactly for us. So what is DApp? Oh, and I'll mention as well that we've now since moved to DApp, and, you know, it's pretty sweet. So what does DApp do? It does the things that we're used to from other frameworks and the Truffle world. It compiles our contracts. We can use it to deploy. We can write inline Solidity tests. So this means tests that are actually written in the language in which the smart contracts are written rather than some other language. So that has benefits. But it also gives us some really cool new features. So one thing that it gives us is a suite of packages. The full name of DApp is actually DApp Suite. And the suite part, you know, is a huge assortment and growing, I suppose, of packages that play really nice together. So they'll do one thing, sort of the Unix philosophy. They'll do one thing each and one thing well, and do only that thing. So simplicity, and our job then is to compose these smaller pieces into a more coherent whole that we can use for our custom needs. So this is exactly what we wanted. Another thing that it gives us that I'll talk about again in a moment is a debug-oriented Ethereum virtual machine implementation. So that's a lot of words, but I'll explain it in a minute. Okay, but one of the coolest things that that gives us is actually loose coupling. So what this means is that each of those pieces that I just mentioned, these are not dependent on each other. We can use whichever pieces we want, sort of like Lego bricks, I guess is the stereotypical analogy. You can take these and compose them into, you know, something that's greater than the sum of its parts. So for example, if we wanted a new version of Truffle or another framework, usually you'd have to take the good with the bad. If you wanted new features in the newer version, perhaps there's, you know, some incompatibilities that you'd have to take along with it. But with that and the loose coupling that that gives us, we can just take the good parts and just take what we want. So it's a big improvement. And our job then is to sort of build the glue that holds these pieces together, and that would be things like our own custom scripts. So now I'll talk about, just very briefly, the deployment and interaction steps. So I mentioned that that can give us deployment, but we wanted something that we're more used to. So this would be something implemented in JavaScript. So Web3 JS over here. We moved recently to Web3 JS 1.0, which is definitely a big improvement upon the classical library that we used to use, the classical Web3 library. 1.0 gives us promises and other sort of JavaScript goodness that we're used to as well. But we want to move to Parity JS. So Parity JS is by the Parity team. And since we use Parity as our client, as our way to interact with the blockchain, then it only makes sense to use Parity JS. We get all these, you know, features that are exclusive sort of to the Parity ecosystem. So this is where we are. This is where we're going very soon. Okay. Yeah, I mentioned I would come back to this. This is the Haskell EVM. So this is a Haskell command line implementation of the Ethereum virtual machines. This we can run in our console. And the cool thing about it is that it's actually by the dApp Suite team as well. So it allows us to run our whole sort of development process, our pipeline, in a command line virtual machine. And the coolest thing about it is that you can run your unit tests inside there, which are implemented inside of a dApp Suite module. And another neat thing is that you can debug contracts at a very low level, so lower than the Solidity code. At the beginning, I mentioned that we compile the Solidity code down into something that the blockchain understands. This is at the same level of what the blockchain understands. So we can get the lowest, the highest resolution, the highest level of detail when we're debugging. And this is essentially as good as it gets for debugging. Okay. And now I come to Oriente. So Mona mentioned that Oriente is sponsored by Melonport. It's a smart contract analysis tool, and what it does is it attempts to fill in the semantic gaps or bridge the semantic gaps between what a developer thinks that their program does and what it actually does. So this, you know, can be due to sort of a compilation step or a development step, but it can also be due to human error. So what it does, in a nutshell, is it builds a set of paths through a contract, a set of possible routines that can be run. And then it analyzes each of these paths and shows with an extremely high degree of certainty that a certain set of properties is or is not present. These properties are linked to known exploits or known bugs. So we, you know, as long as the properties map to these bugs, then we can be, you know, pretty sure that these bugs are not present in our code if Oriente gives us sort of the green light. And what does this give us, Oriente? It gives us confidence in our contracts. So like I just mentioned, if we get that green light from Oriente, then we're good to go, at least for these known exploits. And also what it gives us is another tool in our development kit. So I mentioned we have inline Solidity tests. We also have integration tests, which are in Jasmine, which is a JavaScript library. And then combining these two with Oriente, we sort of have a three-pronged approach to testing. Then you build on top of this our regular audits, which we've done and we do now and we'll continue to do. Then we can be very certain that as we add code, we're not regressing to a state where we introduce bugs or problems that can lead to loss of funds. So, in conclusion, I'd just like to say that if you're not a developer and you're in the audience, then I hope you learned something about Solidity development today and sort of what goes into our tech stack. This has never been done before. I consider it the next generation of Solidity programming. And if you are a developer, that's where I'd like to go, is to start a conversation with you. I'd like you to go on our website, on GitHub specifically, check out our tech stack. If you see a problem, file an issue, of course. But most importantly, leave some comments. Comment to us at the conference or by correspondence later. And yeah, so let's start a conversation and let's move Solidity development into the next generation. Thank you.
We're going to continue with a short demo of Oriente from Joey Krug. Need to set it up first. All right, super Joey. Here, is this the kind of hole that you need?
Yep.